Okay, so we have the continuous random variable x. It has a probability density function f of x, where x is defined as a quarter between 0 and 1, where f of x is defined as x cubed over 5 for x between 1 and 2, and 0 otherwise. We're asked to find capital F of x, which of course is the commutative distribution function. Okay, so first of all, we're going to find a function for the range for x between 0 and 1. So what we're going to do is we're going to integrate between the lower bound, 0, and t, which is a dummy variable to form our equation. We're just going to be integrating a quarter. So it's a nice straightforward function to integrate here. When I integrate a quarter, it's a constant, so it becomes x over 4, integrating that between 0 and t. So then substituting our values in, we get t over 4 minus 0 over 4, and that gives us a value of t over 4. Okay, and this is now going to form our equation, our commutative distribution function for x between 0 and 1. Now, when I come to doing the function for x between 1 and 2, what I need to do is I'm going to need to integrate this function here and form an equation, but also I need to take into account all the probability accumulated during this first range. So to do that, what we're going to do is we're just going to quickly calculate f of the upper bound, so f of 1. So I'm going to get 1 over 4. So in this first function, we accumulate a total probability of a quarter. And what we want to do is we want to make sure that we take account of that when we come to doing this commutative distribution function for the range 1 to 2. So what that means is when I actually come to do that function, f of x is going to be equal to f of 1. So that's that shared bound. So this is going to add that extra quarter in that needs to be taken into account for the first probability density, commutative distribution function. Now, what we're going to do is we're going to integrate the second function between the lower bound, which is 1, and again t, that dummy variable. We're going to have x cubed over 5. I tend not to take the constants outside when it's kind of like just one simple term. If I have more than one term, then I take the constant outside. I might take that fifth outside, but here it's fine as it is. So f of 1 we've already evaluated as a quarter. We're then going to add the result of integrating x cubed over 5. So x cubed becomes x to the power of 4. Divide by that new power, so divide by 4. That means we get 5 times 4 on the denominator. So I get x to the power of 4 over 20. Integrating that between 1 and t. So we're going to put in a quarter, and we are then going to add x to the power of 4, so putting in the t, we get t to the power of 4 over 20 minus 1 to the power of 4 over 20. Okay, so what happens now, when I evaluate this, I obviously get left with the t to the power of 4. Here, I get then minus 1/20th. So when I add that quarter, this then simplifies to t to the power of 4. And you can just do the quarter minus a 20th on your calculator. So t to the power of 4 over 20 plus 1/5. So it comes out as quite a nice tidy function. Now remember, when we come to actually finishing this question, we just need to define the commutative distribution function for f of x over all possible ranges. So what I mean by that is what happens if x is less than 0. So if x is less than 0, then your commutative distribution function is 0, because we can't have possibly accumulated any probability. Next, we have our function t over 4, or x over 4. This is for when x is between 0 and 1. And then finally, we have our second function here that we've defined. So we're going to have x to the power of 4 over 20 plus 1/5. That's going to be for the range 1 less than or equal to x less than or equal to 2. Finally, the last range just to deal with, of course, when we've added up all our probabilities, when we've accumulated our probabilities, by the time we get to 2, we've reached total probability. So then any value greater than 2 will give us a response of a probability of 1. And that is our cumulative distribution function over the different ranges. Hope that all makes sense and that you've understood it.